morning, good afternoon, or good evening, depending on where you are in the world. So it's good morning to the Americas, good afternoon to Europe, Africa and the Middle East, and good evening to the Far East, Australasia and Oceania. You are very welcome to today's PETinar, the second of two this week, in which we are looking forward to Drinktec 2022, which takes place in just 2 weeks from now, from the 12th to the 16th of September at Messe München Trade Fair Centre in Munich, Bavaria and Germany. Now, before we get going, I'll just share something with you. I received a press release yesterday, actually while we were on air with the PETinar, telling me that Forbes magazine says that food and beverage is among the world's top 12 industries with millennial billionaires. It stands in 8th position with 4 billionaires. Their combined worth amounts to $18.4 billion, which should come in handy for paying this winter's energy bills. Now, I don't know if any of them will be at Drinktec this year, and it's been 5 years since the last Drinktec, and a lot has happened in the intervening period, not just COVID and Ukraine, but a lot in the food and beverage packaging industry, from legislative measures like tethered caps and single-use plastics directives to the drive for lighter weighting and for increased environmental responsibility, which is significantly driven by consumer reaction. Now, I'm sure that when we get to Drinktec, we will all be very much looking forward to the chance to meet suppliers, customers and colleagues in person again. Now, we've been in isolation for too long. Online communications like this are great, but there's nothing quite like the personal touch. Now, we've got quite a lot to cover, so we're diving straight in, but just before we do, a little housekeeping. There will be time for questions after the presentations, and we will take them all at once. Please use the message function. It should have a chat button up towards the top if you wish to put a question. And please open your post with the name of the presenter that you wish to put the question to. It'll make it a lot easier for me to keep track. Now, the running order for today is first, we're going to hear from PackSys Global, then from Sacmi Imola, and then from StackTeck. StackTeck, yes. Then we will discuss your questions. Please feel free to submit them during the presentations when they occur to you, but we won't answer them until the end. First up, I am pleased to introduce Mr. Uli Kobel, who is International Sales Manager and Product Manager, Beverage and Specialities Division with PackSys Global. Mr. Kobel joined the company as an industrial engineer in 1994 when it started developing equipment for the plastic closure industry. In 2001, he was appointed Technical Sales Manager globally. He later took on the roles of Global Key Account Manager and assumed responsibility as Product Manager for the plastic closure segment. He's going to talk to us about the latest developments for tamper-evident band forming equipment. Uli, over to you.
Thanks, Rory, for the introduction. Thanks, PETplanet, for this platform to present the latest developments on PackSys Global on this PETinar for the Drinktec exhibition. We are all excited to be together after 5 years break at the Drinktec in Munich. PackSys Global. PackSys Global is a subsidiary company of the Büchler Group. I have to take the control. Good. Büchler Group, a family-owned company with the 4 main companies: Büchler Maschinenbau, Büchler SurfTech, Kiefel Technologies, and PackSys Global. The company Büchler has about a turnover is about 1.2 billion in all the plastic packaging segment. It's headquartered in Bavaria, in Sixdorf, Germany. We have nowadays, it's more than 2,500 employees worldwide. It was founded by Mr. Büchler in 1960. And I'm pretty sure all of us are on a daily basis in touch with the products made out of the Büchler Group machineries, whether it's for electronic components, cosmetics, healthcare, personal care, food packaging, last but not least, also for the beverage packaging. PackSys Global, one of the 4 platform companies, or one of the 4 companies in the Büchler Group, has its 4 divisions. So we are in the business for about 50 years, and not long back, we've set up the new division organization. So we have the divisions Health and Pharma and Premium Cosmetics, mainly in the tube sectors, for decoration as well. Then we have the Beverage and Specialties. That's where also the closure business belongs to. And we have the 4th division, which is then the customer service for all the all the 3 other divisions. We are globally set up. We have our platforms in the US, in Portsmouth, New Hampshire. We have in China, in Suzhou, our platform. We have in India, in Mumbai, our platform. And then we have representative offices in Japan and Brazil for the Latin America, respectively, the Japanese market. PackSys Global was founded in 1996. Today we have around 300 employees on a global base, and we have in Switzerland the 3 headquarters, whereas the major office is in the new building. Just recently had the opening ceremony in the beginning of July in Rüti. Then we have an office in Burgdorf, and we have a factory in Haldenstein, mainly for the end-of-line packaging. Let's focus a little bit more onto the closure. What happened? So in the past 50 years, or a little bit more, PackSys was always in the business of closures. Half of it in plastic, and before in metal closures. Today we have more than 500 slitting machines just for forming or finishing the temporary evident band in the market. Looking back in 1995, when I joined the company, our typical production rate was at about 1,000 parts per minute. Today, we are able to process 3,500 parts per minute, depending on what the molds or the forming machine in front of has an output. We had quite a transition in the sequence of finishing the temporary evident band. So whereas first no folding was required, today we are going for slitting folding. Before we have to fold and then slit. So it depends how the closure is designed. But with lightweightening, we are going more and more towards slitting and folding. And of course, tethered, this is the main subject for the European market today. This is beside the sustainability, alternative materials, the main driver today. So we are always following the market needs and the latest technologies. We are just a part in a complete production line. Few key points about our existing portfolio. So what we are going to show at Drinktec is our TEM machine. That's let's say the latest developed machine for specialty closures, whether it's for sports cap, for large diameter closures, for all kind of different closures for the carton industry, where we have to slit in front of the assembly process or after the assembly process. It's a little bit, let's say, for non-flat, a little bit more complicated closures. We invented 3 years ago the cap lab. So it was the first time in forever we had brought a lab equipment into the line. So that device in the center of the picture, or on the left hand of the picture, is a disruptive testing method to evaluate the right pull strengths on the plastic closures, which is essential for the consumers to feel safe when opening a bottle for first time. And of course, as I said, tethered closures, we had to find a way, all the existing equipment can be adapted also to tethered. So that was the driver for us to develop technologies, which we call today Expert Tether, Smart Tether, and Cap Compass. So with these 3 technologies, we are able to serve the tethered market on a good platform, whether it's for oriented slitting, which is Cap Compass, Smart Tether, it's a hybrid solution or expert tether, where we have the contour slitting. So whatever contour we want to have on the TE band, forming a hinge, creating a temper evident band, that's the technology to go with. And this is exactly what we implement to the machine at TEM, which we have at the Drinktec. So when you talk about closures, tethered closures in particular, we talk about all kind of closures which comes in various shapes, but the main functions remain the same. So the sealing should be the same. We want to prevent entry of any micro particles, the O2 loss. This we want to protect. And of course, not the temper evident band that needs to be there as well, with the same functionality as we know from today's non-tethered closures. But the consumer experience then also wants to have the same behavior. So with the grip zone, the radius, all this convenience, it should flip away in the right direction. Since it's being no longer detachable, it should be in a convenience direction to get out the content. And of course, the industry, the manufacturers, they want to have also the requirements. So the investment should be as low as possible to transit from standard to tethered closures. The filling line, it's important to have not a major change in the capping process. The efficiency, zero defects, all these factors are highly sensitive for the converters, for the filling lines. Today we know two technologies. On the left-hand side, we know the slit hinge. On the right-hand side, we see the molded hinge. This is the product from one of the global major brands. On the left-hand side, we have a 500 ml bottle, whereas the other one is 300 ml bottle. So it's obvious there are different technologies possible. Let's talk about the technologies first, about cap compass. That's what we developed mainly for the carton industry, for multi-piece closures which are assembled with a cutter, with a spout, or just with a spout. It requires a defined hinge position, and this is what we do with movable spindles. We go inside the closure. We have the orientation sequence before we then start with the cutting right at the point it's foreseen, or it's ideally positioned. It's possible to have this with vertical slitting, multi-level lines, 3 lines, 2 slitting lines, whatever is needed, we can handle it. The second is expert tether, and the expert tether, that's a technology 5 years back, really nobody was thinking about that, where we have the contour slitting. So each time a mandrel passes along the outer tooling, the slitting knife, it's fully synchronized. We know it from high-speed machines, where we've delivered a good number of machines which are in commercial production already. This is the most seen technology today we deliver in the market for the beverage industry, for PCO 1881, for the GME 30 point whatever. This is the future. A big advantage is with the third technology, smart tether. So smart tether is kind of a hybrid solution between expert tether and let's say the standard we have today. It allows our customers to run the same closure design for tethered, but also as a standard. The changeover from tethered to non-tethered is done in 3 minutes. Changing the knife, it's there. It's thanks to the modularity we have in our machines, we have a very, very quick and very low cost or low investment changeover between the two solutions. The same closure design, but different technology in the slitting process. This for sure is a big advantage if we go with post-molding slitting compared to the slides in the mold. So the 10 Plus in general, I mean, I have to highlight again, we have one knife that cuts all the closures coming out of whatever it's a 96, 72, 64 cavity mold. We have one knife that forms all the bridges in coming out. We are very flexible on that machine with the sequence. We can in the field we can switch between folding, slitting, slitting, folding, or just slitting or just folding. That's a modular machine base where we have all these opportunities. It is a very gentle product handling, so the closures going inside the machine are not moved in a vertical direction. So in other words, we are moving all the spindles. That's the principle on the TEM machine. The specs for that machine we are displaying at the Drinktec. We have a nominal diameter up to 38. I think that covers most of the beverage container closures. The height is there. We have different speed modes depending on the can. The process sequence, as mentioned, is very, very flexible, whether folding, slitting, or whatever is required. The second point we will display at the Drinktec is CapLab. Okay, some of you might say, hold on, that's the device you displayed at the K. That's correct. 3 years ago, we were the first in the market having this testing device in line with closed loop operation feedbacking to the molding machine, whether we are in the target range or not with the band breaking strengths. We have still various patterns, whether it's according to the cavity or according to the spindle of the slitting machine when it's slit, or we have by time, by volume, all is adjustable. We can adjust the pattern, whatever is needed. All the data, the measuring data, are transmitted to the system. Either we provide the platform, but more often, I think there in the manufacturing hall, there is already a system in place. The big advantage, why did we bring CapLab onto the line? We always have the same conditions. So the crystallization of a closure is at the same level. The temperature is in the same level of the closure. And we are independent on the mood of the operator in the labor, where normally these testings are done. So we have interviewed a couple of manufacturers to see how it's being done, and we found out there is a big difference between the individual manufacturing companies in the plastic closure. So just generic, what we do, we have a feedback to the injection molding machine when we just would run without slitting. So we would feedback, hey, cavity number 32, there is an issue. The strength is not in the target zone. So it can alert the operator to close the cavity or maintenance work. Or we can feedback to the slitting folding machine and say, okay, spindle number 4, there is an issue. We should think about and measure it again or whatever. So we have all these analyses. If in general the strength of the TE band separation is getting too high, we can increase the temperature of the knife and bring it back in the target zone. So we have this closed loop feasibility to run the line without human interaction. So this is what we had, and this is what we keep. We just thought, okay, let's go with CapLab Plus, and we did some more processing or testing methods. Some measurements are done there. So of course, tethered, it was when we started with CapLab, not the major major goal to implement. So today, I think we have to. TETit is the future, at least in the European market. Let's see where the journey goes on after Europe has converted in about 22 months. So what we also did is another measuring. I will not display, I will not explain today. You are very welcome to see that in Munich, in our booth in hall C5 at the booth 330. There you can see the additional technologies we implemented to CapLab. Thank you for your attention.
Thank you, Uli. That's very interesting. And as you say, I think sustainability is the main driver today. I expect we will hear more about it, not just today, but over the coming weeks, months, and years. And now for our second presentation, I am delighted to introduce Mr. Jacopo Bianconcini. Jacopo joined Sacmi Group in Imola, Italy, 21 years ago. He graduated in management engineering at Greenwich University in London and added a master's degree in marketing, innovation management and digital transformation at SDA Bocconi of Milan and Columbia University, New York. After gaining experience as an area sales manager and key account manager, he is now based in Sacmi's Imola headquarters, where he is directly responsible for marketing and product development activities within the rigid packaging technologies division. Jacopo, we're very much looking forward to hearing what you have to say today. Over to you.
Thank you, Ruari, and hope you are hearing me properly. If there is some noise, like it's raining cats and dogs here. Italy is said to be the land of sun. It was in the last 3 months, but not in these days. So I'm just trying to take control of the presentation, which I guess is working perfect. So thanks for hosting us here and giving us the possibility to show our innovation and our technology and our topics, which we will bring in the Drinktec coming exhibition in a few weeks' time. So what we will show you today is on real, both the technology, the software and the hardware present at our booth, working at our booth. So a lot of people will talk about sustainability and digitalization. We will actually show that on real terms. So this is a whole B5, and this is where going to be our booth. So very quick introduction on Sacmi. We are a company for more than 100 years, founded more than 100 years ago in Imola. This is a picture of the people working at headquarters here in Imola. Our motto is we don't just sell machines, we generate trust. Why? For different reasons. One is because we are a group of 80 companies, 10 of which are manufacturing ones, and physically present with the services, distribution, and production in 28 countries. And the physical presence of our machines is in more than 100 countries. We are talking a lot of sustainability on the product, on the process, but also there must be economic sustainability of companies. We are said we are there since more than 100 years. Here is important to notice not the revenues only, but the number of export. Almost 90% of our product is exported out of Italy. And it's important to have a look on the equity and on the margins, EBITDA, and on our employees. We are about 5,000 people worldwide in Sacmi. Again, sustainability is how we work, how we produce machines. We pay a lot of attention on how we get the electricity, obviously with the solar panels, not today. On water, on try to prevent water consumption and save waters, and also to deal with the proper waste. Again, sustainability is on how we provide a competitive advantage to our partners and to our clients. Just a couple of numbers here. We have more than 5,000 patents. We have 100 partnerships with universities and research centers globally. And there are more than 300 higher qualified technicians and technologists working in R&D and on innovation. We dip only into the rigid packaging technology, which is the division I represent and on which is based the presentation of today. What we do machines for rigid packaging, caps, preforms, containers, plastic, metal, and in a very short time also paper and fibers. So we have a really 360 overview on this packaging market. Mostly we are on food and beverage. Now we are entering the pharma and the home and personal care ones. Again, sustainability on the products is all our industry is known to be in view of the 3R, which is reduce, reuse, and recycle. We will show at the exhibition how we use rPET recycled plastic in our injection preform systems. Again, there will be a section in the Drinktec only on tethered caps and on our solutions, slitting solutions like Uli presented before. Not by mold, by slitting, and also our lab certified by the major brand owners, which actually designs preforms caps and bottles, and is aiming to a really important weight reduction. We reached in the last decades about 50%. But focus on what we will show at Drinktec. The presentation title is How to Translate Digitalization in Closure Manufacturing, in this case, into a real economic advantage. And there are three main topics. One is the generation of data, one is elaboration of data, and one is how to get this into profitability. So let's start with the generation of data, which is the section on which I will spend most of the time of the presentation. What we are talking about, this line, which you see here, this is exactly the line which will be presented and working, actually producing caps at Drinktec. I would like, going from here, how it works is a production of plastic caps by compression. So you have an insertion turret, which takes the pellet dose from the extruder and put into the main turret where it's actually molded and cooled. Then it takes all the way down into the slitting and folding process. Again, this is where we will have the machine at Drinktec. How to generate data through a package which we call the Smart Pack, which is a sort of onboard hardware and software which maximizes flexibility and on real-time adjustment of the machines according to the data and the process they figure out and they text during production. It's a package which comes as a whole and consists of four main aspects of the process. One is the pellet insertion, which in compression technology is a key area. One is advanced management of materials control. So we will see and we will perform also in the exhibition how changing from one material to another one, the material actually detects automatically and then sends an alert. Then we will talk about thermic controls, temperature control system in the mold and in the machines as well. And on the hydraulic system, we all know that oil is sort of the blood of the machines, and it is very important. We have systems on able to detect in real term in the machines if there are particles, the chemical of the oil, and we'll talk about this later on this presentation. So let's start with the pellet insertion. If hopefully the presentation will move forward. Here we go. There is a video also here. So it's like playing basketball. You have a ball and you have to throw the ball in the basket and hopefully center it. So this is the target of the insertion turret. We have a set of positions that with a pinhole and with compressor there, they take the dose cut from the extruder and place into the mold. Here we are able to digitalizing the position of the dose into the mold, each position of each dose. So this means that you have a statistic and a behavior, and you can detect if there is a drift in the process and actually act before the problem occurs. We have real data that, especially when you have to change materials on the same cap or colorants on the same cap, or even change the size, you have a complete changeover of the caps, then there is the process of setting the parameters. Okay, you have your receipt downloaded in the machines, but always you have to check that. With these sensors and knowing exactly what you are doing in the machine, and in the same time what is happening in that part of the machines with these actual controls, you know exactly what is happening in real time and adjust correctly. And we discover that you save half of the time in the setting time moving from one receipt to another one. What does it mean? Less scrap, more production, more money at the end. Again, easy control of the pellet insertion. Here, with this video, we will show how you can spot a complete drift, not only in one position of the insertion turret, but something happening as a common parameter, no? In the process. You see that all those from every insertion points are drifting away from the center. So something is happening. Maybe there is something wrong in the insertion time, something wrong with the speed on inserting the dose. And again, you are actually knowing what is happening in real time, make an intervention and solve the problem because the problem appears, because you know in advance what is happening. This has to do also with the wear of materials. I cannot be precise here because we have patent on this and it's a very important know-how we have. But again, it has to do, I can tell you, it has to do with the pressure of the chamber of the pistons placing the dose down. And we actually can exactly know which situation is happening and if there is a wear or not. So we can act on this, moving the time of the intervention for maintenance. Can be earlier than previewed by the manual or later, hopefully later. And we see how this can have an economic advantage later on in the presentation. So we move we leave the pellet insertion. Now we move into the following section, which is very interesting. When incorrect resin detection. If you move, this is what is actually have been done on in real term, moving from the hopper from one resin to the other resin. It has to do with it's an algorithm patented by Sacmi. Has to do with the rheological stuff of the resin, and the machines detect that is not the same resin in the receipt and gives you an alert. So again, you know exactly when the problem is happening, and you don't waste scrap, time, loss of production, and again, we are back into economic advantage. Color change. Our technological and technical department prefer to call it assisted color change. I will call automatic color change, provided you have the proper material and the proper color in the hoppers. But then just by pushing one button, which I'll go back, I'll show you here, this one, exactly that button, the machine automatically perform the color change. The continuous compression molding machines actually works in conjunction with the computer vision systems which detect the color of the caps, the transition of the color of the caps. So the caps going into scrap, taking out of the production line, but then automatically the machine detects when the color and the dimension of the caps and all the data of the receipt are met. And in that case, no more scrap, automatically back into the production bin. So again, you save a lot of time here and no errors, no human errors. Other two parts on data collection is important. I mean, as said, the oil is the blood of the machines, no? So we have sensors and we have devices to analyze the quality of the oil, both in physical terms, dust or whatever particles, and on chemical terms. So how the decay of the oil. And again, by analyzing this data, it is possible to properly program the maintenance intervention, knowing what is happening. Maybe postpone compared to the table, because it depends according to how many hours of production, which kind of caps, the maintenance done before. A lot of data. You know exactly what is happening in the machine in real terms. Finally, on collecting data in a rotary machine, the rotary joint is a very, again, key point. And we have, again, sensors and we have systems to know exactly the health of all the gaskets. So to check if there are leakage and how is the situation, again, to program the maintenance. It's important here that we have a system also for the accumulators. That sometimes it's very, if you see that you are losing pressure from an accumulator, it means that something is happening there and you can intervene there before the problem occurs, which it happens, and we have some evidence that sometimes there is something going on in the machines, and you have to make a lot of tests, a lot of trials to know what is that, and then you discover is an accumulator. With this set of smart pack is a problem you will not have anymore. So, so far we have spoken how to collect the data, but how to elaborate that, because you have to proper use system of machine learning, artificial intelligence, which we have patented, and then they are all in cloud. And then on top of what you can get from the smart care in real time on the machine, of which we spoken earlier, then with this system, you can have a sort of, how to say, prediction on what is going to happen in the future in the machines. And the more you use the machines, the more you get data, the more the prediction is accurate. And on top of that, you can get data-driven decisions. There is an important, so again, here is exactly what I said, collection, trend and monitoring in long term, data processing, predictive maintenance alerts, and also the KPIs. You can set the KPIs you want. It's important here to notice that you can forecast, as said, future behaviors, but also get analysis of the data you had. I would like to focus on a specific case study, which you'll see better in the next slide. But in any case, you can spot from here. Again, now it's coming. You can compare two same cap, same machine, same production, two different resins. In this case, we have two different resins. And then you have how much is the consumption of the production line with one resin or the other resins, how much is the scrap rate, one resin, the other resin, same cap, same production rate, and adding the cost of the resin, which you know, then you can make an analysis what is more convenient to use. So which material is best for that particular cap, which one gives me the higher performance or the less costs, and with this set of data, it's easy to make this a smart decisions. I will not focus much on this. You can come visiting in our booth, and then you will have proper information on that. But in any case, there are different type of proposal of smart care. One is you have access to the platform and you make your own KPI and data. You can have a remote engagement with the Sacmi team, or you can add a step further with the maintenance contract, with the predictive maintenance contract, and then somehow we take care of your machines and you know exactly the production and the costs. Finally, profitability of data. We already entered into this topic. I have just the final 2 slides on this. Case study, I cannot disclose who is the customer and where and on which machines. Anyway, is a continuous compression machines. We took 2 years, 2021 and 22. Every 15, more or less, every 15,000 hours, sorry, we have to make a maintenance program. They have 2 exact machines with the same product, one with the data with the smart pack and smart care, and one as a standard. With the one with the smart care, they saved in this, let's say, 2 years maintenance, main maintenance, 22% saving in employee time, 20% saving in spare parts, and 58% in not losing production, so in more efficiency. It really depends on the type of machine and the caps and the hours, whatever. But I can tell you that in this case, just with this, they saved more than 20,000 euros just in one maintenance program. This is what I showed before on raw material savings and comparing the resins. This is a real case. So with 2 resins, one you have a bit lower energy consumption, but 2% more of scraps. So again, it depends on the cost of the resin, and according to that, you can make the decision. This is the last slide of my presentation. All what I spoke, you can have an experience live in Drinktec. And for any question, I'm here, and thank you for your attention.
Jacopo, thank you very much indeed. I noticed that you said 1,500 arias rather than 1,500 hours, just there, very Italian.
15,000 hours.
50,000 hours. I thought 50,000 arias. I thought how very operatic, how very Italian. Anyway, you're absolutely right about sustainability. As it happens, I've just written a white paper for a technology company that has a section on sustainability, and they too were very keen to emphasize that commercial sustainability is vital as well as environmental. And if your company is the green dream but goes out of business, it doesn't really do anyone any good. The point that you made about effective monitoring and maintenance being key is very well made and very pertinent. Thank you. Thanks again, Jacopo. I look forward to speaking to you again in a few minutes. But last but by no means least, we have a presentation now from StackTeck, which is going to be given by Jordan Robertson, a graduate of McMaster University, which is in Hamilton, Ontario, in Canada. He has a bachelor's degree in mechanical engineering and an MBA, and over 30 years experience with injection molds and systems in packaging applications. Jordan is an officer of the SPI RPPG, that's the Rigid Plastic Packaging Group, and a board member of IMDA, which is the In-Mold Decorating Association. He joined StackTeck in 2001 and is now Vice President of Business Development and Marketing. Jordan, the floor is yours.
Thanks very much for that introduction, Ruari. And thanks very much to PETplanet for creating this platform and this opportunity to talk about a new innovation that I'd like to go into some detail on today, specifically P-Cool technology. But before I get to that, in case anyone on this PETinar may not be aware of StackTeck, we are a large mold maker based in Canada, focused on applications for packaging, personal care, and medical. And that range of applications does include PET preform molds as well as molds for tamper-evident beverage closures. Today, we're going to focus quite specifically on post-mold cooling for PET preform applications. And we are showing a little tornado here on the introductory slide. I'll explain as we go through why I have that there, and hopefully it'll be quite apparent why that's a logical symbol for the P-Cool technology that we're going to be talking about. in this image here, we can see a fairly traditional approach to post-mold cooling for PET preforms. On the left-hand side, we have a multi-position takeoff plate. On the right-hand side, we have another plate full of blow pins that is aimed downwards. All of that is relatively what I would call conventional for PET preform molding today. What is new and different, and we're going to be talking about, is the configuration and the geometry of the airflow inside the preforms as generated by the blow pins. And I will just play this video briefly. It's a 96 cavity system with a 4-position takeoff plate, and as you can see, it's a high volume, well optimized system, and we'll speak to the details of that system as we get a little bit further into the presentation. But before I get ahead of myself, I just wanted to define terms. As I reference conventional post-mold cooling, what I mean by that is obviously including the end-of-arm multi-position takeoff plate, as well as a set of blow pins. And when we say conventional, what we really mean is that either a simple pin is inserted into the preform and compressed air is blown into it, and it exits cooling the inside of the preform in a linear fashion, or it is drawing a vacuum, and again, the air passing by the inside of the preform is moving effectively and typically in a line before it is sucked into the tip end of the blow pin. And P-Cool works differently from that, and we will elaborate in a moment. Here are some images of a hot PET preform, and the images are taken seconds after being molded, and we're showing 4 different views while rotating the part by 90 degrees between each picture, and it's quite apparent from these images that the amount of heat in the part is not consistent as we look around the perimeter at a certain elevation, and then as we look up and down at different elevations from top to bottom of the preform, it also is apparent that the cooling, that the temperature of the part is not consistent. And of course, everyone in the business is familiar with the kinds of challenges that can arise when there are inconsistencies in temperature, as shown in these pictures. And I also want to mention for these images, these are taken of parts that have just come off of our development cell running an 8-cavity developed PET preform mold, and was done in basically an R&D lab setting. So P-Cool is different from conventional blow pins in that we are using a special fixture that is near the mouth of the preform, and it induces a spiral pattern on the air, whether you may blow in through the blow pin or provide suction like vacuum, as is shown here in the diagram. Whether you go in either direction, we effectively have some little vanes, not unlike a jet turbine, that induce a rotation on the flow of the air inside the preform. So it is moving very differently than in the conventional case. The diagram is quite simple. StackTeck, by the way, was granted a patent on this technology in 2018, and this is still a relatively new technology. Now I'm going to show you a video where we are manually holding a preform over a P-Cool pin assembly, and you're going to see, because we have put some liquid droplets inside the preform, it will enable you to see the pattern of the air going inside. The angle of incline of these droplets moving in the preform is roughly at about 45 degrees, give or take. And that, of course, changes the nature of the degree of turbulence going on inside the preform. It also makes for more consistent cooling around the perimeter because the same air is traveling around and around the inside of the preform before reaching the tip of the blow pin, or I guess I should call it a suction pin in this case. So that is what is new and different with this technology, and why is that important? Going to first talk for a moment about that video I showed earlier on. It was a 96 cavity system. It was a 96 cavity StackTeck preform mold running in a Netstall PET line 4000 system. As you can see here with this pin plate, we have 3 positions at which we are blowing, and then a 4th position which is strictly for ejection in the 4th stage before ejection. And I want to touch on a first case study of 2. In this case, it's a 42 gram preform with a wall thickness of 4 millimeters that has a base cycle time of 14.9 seconds. And we're showing in the images with 1, 2, and 3 stages the conventional technology as compared to P-Cool, and the temperatures, which I'm not sure if you can read them, but the end of the first stage with conventional cooling, this preform at the location shown is 94 degrees Celsius, whereas P-Cool is 87.5 for a difference of 6.8 degrees Celsius after 1 cycle of post-mold cooling. At the end of the 2nd stage, it's a larger difference, and by the end of the 3rd stage, running at the same cycle time, the preform is 15.7 degrees cooler, and this is strictly the result of changing out from a conventional blow pin to a P-Cool blow pin in the same system, running the same material. Everything else is held constant. And so, of course, as we saw this improvement with the technology, we then moved to reduce the cycle time, increase the productivity, and we were able to compare to the 61.1 degrees Celsius at the end of the 3rd stage of cooling with the conventional pin. And once we had reduced the cycle time by 2.2 seconds down to 12.7, that temperature at the end of the 3rd stage of cooling was at 59.1. So still just slightly cooler than the conventional case, but running significantly faster at 12.7. And of course, that's extremely interesting when you have a large asset like a PET preform system that is not inexpensive. And if you can take an asset like that and increase its productivity by that kind of proportion, that brings a tremendous amount of value. And the only thing that we're changing here is the post-mold cooling inside the preform and fundamentally the flow pattern of the air going on the inside of the preforms. I have a second case I'd like to review. This is for a smaller preform, just to show it's not just a one-off case. In this case, it was a 72 cavity system for 16 gram preform. In that case, we went through a similar process, and while maintaining the exit temperature that we had been at, we were able to either at the same cycle time reduce the temperature of the preforms by 9.4 degrees, or conversely, at the same temperature, we were able to reduce cycle time by 1.3 seconds, and again, a substantial proportion of the cycle time going from 10.98 seconds down to 9.64. And so as a general rule with the P-Cool technology, we have found over a variety of different applications that the overall savings using this technology, in our experience so far, has been in the range of between 5% and 15%. Whether the higher end of that range or the lower end of that range, bigger is better, of course, but even at 5%, that's a substantial change and improvement, considering that we're not really changing that much in the system. I will also mention this is a technology that can be used on existing systems with relative ease. So we will be showing this technology. StackTeck does have a booth at the Drinktec show coming up starting September 12th. We'll be in booth C5, and we'll be delighted to talk about this technology and other technologies related to what we do in molds for PET preforms, as well as I mentioned before, we do a lot of molds for camper beverage closures. Please feel free to stop by the booth. And again, I'd like to thank PETplanet for this opportunity to speak to you today.
Thanks, Jordan. Thank you very much indeed. Sorry if I look slightly distracted. It's because I've been dealing with a couple of questions that have been coming in, which is great news. Thank you very much indeed for that. Now, one thing that I notice and say, yeah, I mean, achieving reliable temperature management while reducing applied heat and cutting cycle time is quite a challenge, and so congratulations on doing it. And the contribution to cutting energy costs will be, I think, particularly helpful in the current circumstances. I've just been reading about somebody whose electricity bill has, or proposed electricity bill has gone up from £300 a month, which is already quite a massive leap, to over £700 a month. I said to him, if you've got a floodlit sports ground, that sounds like a bargain, but if you're at home, it's bad news. But anything that can help contain and control energy costs is to be welcomed. Thank you. Now, actually, as you're there, I will ask a question to you first. Now, do you have any experiences with processing preforms made out of rPET, so recycled PET? Is it working in the same way?
So actually, that's a really good question. In fact, at the last K show, we had the display front and center of the StackTeck booth was showing samples and a customer testimonial related to an rPET application that has been running in Canada for some years, where it's 100% rPET, and the details of that actually are listed on our website. Our customer was very generous, allowing us to show that. And yes, absolutely, the cooling of a PET preform, whether it may be made from virgin material or from rPET material, the cooling will be enhanced in a similar way. We've never done a study of what's the difference between virgin material versus rPET. However, fundamentally, we would expect the same proportional improvement with either material. Okay, so you're talking about proportional improvement, but as we know, sometimes the actual processing of rPET, because of changes in its chemical composition and sometimes degradation over a number of cycles, can make working it a bit awkward. But have you not come across that as yet, or have you overcome it? So I have the one rPET case to point to. We have used PCool on rPET. Okay. For cycle time improvement. Whether it's a greater improvement than virgin, I'm sorry, I actually don't know. That's fair enough. That's absolutely fair enough, because it's still relatively new in terms of its penetration in the marketplace. rPET is gaining in support and in application and usage, but that's being driven significantly by legislation, and we're still at early days. We haven't really, we're at 30% required content at the moment, nowhere near 100%. So we'll see over a period of time. Please stay on the line. I haven't got another question for you at the moment, but you never know, I might get one. PackSys, I've got a question for Yuli. I've got a couple of questions actually. Yuli, if you are there.
I'm here.
Hello. Now, for the transition from a changeover from a single cut to tethered, what do we have to consider in terms of costs and investments and change over time is the question that I've got here. Does that make sense?
Yeah, that makes sense. So it's the question whether it's a complete new closure design in general, or it's an existing, let's say, standard closure with a simple single cut TE band. So for converting that to the tethered application, we're talking about I mean, I will not give here a figure which might be misleading, but I'm very open to get a bit closer discussion at the Drinktec or get a direct conversation started about the costing for that. But it's a minority compared to a new machine. That's for sure. And it's conversion should be done in Once all the parts are available, it's done in a few minutes.
Oh, right. Okay. So that quickly. That's good. Jimmy Chow has asked, is there any specific consideration to the bottle and neck design for tethered closures? Are there any alterations? I think there's a couple of new standards coming in, aren't there?
Well, that's yeah, of course. There is this PCO 1881, which is being replaced soon by a GME 3040. However, a lot of bottlers are still continuing with the 1881 design, and there are some hybrid solutions now are coming up, which is still fitting to the 1881 neck, but can be converted then to the tethered application. So slightly modified closures to get a bit more space to create the form of the hinge, whether it's injection molded or slit after the molding process. There are the solutions. So it's no specific requirement for, let's say, a new standard needed for it. It shall be applicable to all the existing designs. We are talking about sustainability. So we should not add materials. We should save materials. So that's the direction it goes to.
Yeah. Okay. And as we're talking about sustainability, having to invest in new machinery and to actually manufacture new machinery isn't a way of cutting your carbon footprint in the short term, is it? It might be in the long term, but not necessarily in the short term. Yeah. Right. Okay. Correct. All right. Thanks, Julie. That's great. Thank you. Jacopo, are you there? I have one for you.
Yes, I'm here.
Hi. Hi. Can you switch your camera on? Yeah, that's
I'm
good.
trying. Yes. Yeah.
There you are. Right. Yeah, that's good. Now, regarding the elaboration of data you mentioned, the collection of production and process data from sensors, what kind of sensors are implemented and what happens if one of these is not working correctly?
So there are very different type of devices and sensors. I mean, easy one to spot is the camera you have around, but then you have a temperature sensors, and then you have a density sensor. Then there is technically there is a different amount of ones which is better to talk deepen on this on the machines and show, I mean, place by place. If it is not working, there is an alert on the HMI, like for the other parts of the machines, that something is, you have a red light and that is not working.
Yeah, it should be a management by exception, shouldn't it? You can spot that something you're not getting the right data.
Okay, then imagine in the worst case scenario that the machine will not tell you that the sensor is broken, then you don't, in any case, you don't get the data. So
you'll notice. Yeah, okay, that's great. Thank you. Right, I haven't got anything else to ask you. That covers the points, the topics that have been raised. So what remains for me to say is thank you to all the presenters, to Julie Kobel of PackSys Global, to Jacopo Bianconcini of Sacmi Imola, and to Jordan Robertson from StackTeck. That's for today. And from yesterday, Petra Westphal from Drinktec itself, and Alex Büchler of PETplanet Insider, Thomas Schmidt, Group Marketing Director with Bericap, Arnaud Nomblo, Director of Business Development Packaging with Sumitomo SHI Demag, and I think he's watching today, and Michael Fink, Vice President of Sales and Marketing at z-moulds, and also to you, our audience. Let us not forget you. There wouldn't be anything without you. Also, a very big thank you to our sponsors, Bericap, PackSys Global, Sacmi, StackTeck, and Sumitomo SHI Demag. Now, just so as you know, recordings of the PETinars will be available on the PETplanet Insider website in the next day or so. May even be available later on today. I've been Ruari McCallion. Thank you very much for your time. I look forward to speaking to you again soon. Bye now. Thanks.